Welcome to the EWS Data Logger software. My name is Aaron, I'm an Enviro Technician at EWS. The EWS Switch and EMT are a super versatile data loggers when it comes to monitoring multiple parameters for surface water. Here I'm going to show you some basics of setting up a complex config that you may be able to adapt for your own field scenarios. It's also worth noting that this is not a step-by-step tutorial and some previous experience with sensors and data loggers may be required. For this setup, I'll be using an EWS EMT device, but it will also work on the regular switch. You may just need some M12 splitter cables or connectors and to reference the EWS Quick Start guides on our website, ewsmonitoring.com. Today I'm going to connect to a Modbus 485 Doppler velocity meter and vented level sensor. Also an SDI12 turbidity sensor. And the scenario I'm going to imagine is these sensors are going to be installed in an irrigation channel downstream of a construction site in hopes of monitoring and managing the water runoff as it leaves the site before it enters the main drains or potentially a sensitive creek. First thing to check is if any of the sensors use the same communication standard and ensure that they are on different addresses. A vented level sensor and our Doppler both communicate using the Modbus 485 protocol. So we'll have to ensure they have a different sensor address programmed into them. The best way to imagine this is like houses on a street. The sensor address is the house's street number, and each house or sensor has a different number to send and receive the correct messages to. As a house can home many people, a sensor can also contain multiple parameters. This is a register number, and that's the person that lives inside the house. A parameter can be a water level, temperature, or quality, among many more. If we have two or more houses with the same addresses, the messages can get mixed up, and this can cause errors and prevent readings. There are many ways to change the sensor's address, and so it's always best to check the manufacturer's instructions before doing so. But there is a handy tool inside the Switch Data Logger software that can manually send and receive Modbus messages. In this case, I have some internal documentation open, and I know these are the settings I require to input in order to change the Doppler's address from 1 to 2. Be sure the sensor is plugged in and to note down the sensor's new address once it has been changed. Once I know all my sensors are going to be on different addresses, I can plug them all into the EMT. Back on the channel page, I'm going to set up all my channels starting with allocating the input type and applying a label. For the first 5 channels, I'll add the type of Modbus and label the parameters I plan on reading, e.g. the Doppler's level, velocity and temp, and then the vented sensor's level and temperature as a backup. I'll set the start time and reading interval to 15 minutes and warm up to 15 seconds on the Doppler and 5 seconds on the vented. This is how long you need to power up each sensor before you can take a reading. Next, I'll set up the type of SDI12 for the turbidity and set the interval to 15 minutes and then again warm up time of 15 seconds. On the Modbus config page, I'm going to set up all the Modbus addresses and registers. First 3 channels I'll set to address 2 for the Doppler, and the vent sensor on channel 4 and 5 will be on address 1. Next, I'll set up the register for each parameter, then the source/type and endianness. These settings vary across different sensors, so check your manufacturer manuals. They generally indicate where to look for the parameter and what type of response or number is expected in return. The next parameter is the baud rate and parity. That indicates the communication speed and a bit order of the communication signal. This can be set globally at the bottom and can be overridden on each channel if you have different types of sensors working at different speeds. As both my sensors work on different settings, I'm going to specify which settings to use per channel. Moving on to the SDI settings tab for the turbidity sensor, it's a lot simpler, and I'll follow my calibration sheet that came with the sensor and set my address as 0 and measurement as 1. Going back to the channel config, I can press the force all channels and head to the data log page and wait for the sensors to respond. If you're getting sample and reading errors, you may need to check your sensor settings and force or sample channels individually, adjusting start times and warm-ups as required. Just before deploying the device, I was told that the site would also like some meteorological data as well, and wanted to add a rain gauge and perhaps record the air temperature from the EMT as well. The air temp, we will apply the channel type of logger temperature, adding a label, adjusting our interval and setting our warm up to 0 as it's an internal function of the device. The rain gauge we will change to the S2 pulse channel type as we have a spare port on our device, and adjust the gain to 0.2 to match our tipping bucket size. Again, 0 warm up is needed as this mode just counts the amount of pulses or times the connected circuit is closed within the designated interval. Now that we are using the full power of the EMT, I'm going to add a supply voltage channel on a 3-hour increments to keep an eye on how much available power we have to recharge the battery. Next, I'm going to go to the telemetry page and set up the device to transmit every 3 hours. And finally, back on the station config, I'll hit the enter shipping mode button and I'm ready to hand off the device to the installation crew in the field, where all they'll be required to do is connect all the sensors and press the button on the side of the device for a quick install. Hope you enjoyed this demonstration of the EMT. Please check back in on the EWS YouTube channel for more videos and how-tos on interacting with our products in the near future.